I think there's a lot to learn about cloud computing from the history of the just-in-time movement. Toyota's just-in-time model, based on the work of Deming and Ford, revolutionized manufacturing by reducing inventories. And in many ways, cloud computing is the application of just-in-time models to IT. Clouds have taken the concept of moving the inventory into an on-demand moment and applied it to computing resources, storage, and so on, so that you're only paying for things when you need them and as you use them. And this is an excellent model until disaster happens. In Japan, the devastation of March 11th, 2011 happened. An earthquake, a tsunami, and a nuclear meltdown. This is the largest natural disaster on record, estimated at 4.1% of Japanese GDP this year. Every automaker will be affected, but nobody more than the Toyotas and Hondas, who are strong proponents of just-in-time. If you want an iPad 2, you may have to wait because those supplies are interrupted as well. And today we're seeing a huge increase in the price of storage, largely because of flooding happening in Southeast Asia. It isn't just natural disasters. In the US, the 1992 railway strikes caused General Motors to idle a 75,000 worker plant because they had no supply. And this is the downside of just-in-time, something economists and business people have understood for a long time, but that we're only now realizing about cloud computing. There are a number of important studies that cover this stuff. For example, in a just-in-time environment, suppliers may hike their prices to offset the cost of carrying your burdens for you. Just-in-time reduces the inventory in a firm, but a firm may simply be outsourcing their input inventory to suppliers, even if those suppliers don't use just-in-time. Suppliers in Japan charge their just-in-time customers roughly a 5% price premium, and we can expect to see the same thing from clouds. Externalities may be simply hidden, not corrected. In just-in-time, things like traffic delivery are seen as waste because they cause traffic jams and the consumption of fossil fuels and so on. Anything that wastes time, inventory, or generates scrap is a bad thing. And in terms of just-in-time, these things are considered waste. In the cloud computing world, the extra cost of moving things between public and private infrastructure or between end users and centralized clouds is a waste that's built into costs. Just-in-time also assumes a level of price stability that obviates the need to buy parts in advance of price rises. If you think that something's going to go up in price, you could buy that storage ahead of time. As I mentioned earlier, there's a spike in the cost of storage hardware. You could have bought a lot of that when it was cheaper. Because you're using on-demand tools, you can't predict that problem and hoard it. So if an IT component is expected to rise and you own your own stuff, you can buy in advance to protect yourself. With cloud computing, you can't do that. Just-in-time also assumes that the input parts are constant over time, that quality stays good. If that's not true, and it seldom is, then firms may hoard higher quality inputs. We see this with veteran Amazon users who often fire up a dozen instances, test them, figure out which one's best, and leave the bad ones to the unwashed masses. They have no way of knowing why those machines are bad. Maybe they're shared with a noisy neighbor, or they're sharing infrastructure with someone else that's using something bad, or they're in a data center that's having problems. They don't care. They simply hoard the better systems for themselves. Suppliers also require a steady demand to use their capital efficiently. If you're trying to supply an industry that doesn't have steady demand, you're going to have a very hard time managing inventories. And some clouds are subsidized. App Engine, for example, and others lure customer commitment with reserved instances or long contracts. So while clouds are on demand, they'll give you a benefit for doing something that streamlines their supply. As we've seen, unless you control the supply chain, you can't know all the problems, and that includes things like the dependencies between supposedly independent availability zones and so on. As a result, cloud computing users and cloud computing providers could do themselves a huge favor by paying a lot of attention to the lessons learned over the last 30 or 40 years of just-in-time inventories and other supply chains.